what day you're taking the exam. Yeah? Because I need to plan ahead as far as copies. I told period 6 this. I don't think I told period 1. The exam that I'm giving this Saturday and the exam that I'm giving the next Wednesday are completely different exams. They're both APs. They're both calculuses. They both have the same, like, calculator, non-calculator, etc. But they're completely different exams, and you guys just take a second and be like, oh, yeah, that makes sense. Oh, yeah, that makes sense. So I'm going to go ahead and put at the top really quickly Saturday. And we'll do this one AB. And then we'll do Wednesday. So Wednesday after school is the makeup. I just did the parentheses backwards, and that's going to bug me, but it's okay. I'll survive. Here, I'm just going to do 2 parentheses, and then now it looks like a fraction. Anyway, okay. I have Saturday and I have Wednesday. Okay? Yes. No. No. I don't have the resources or the ability to grade. So I'm only able to grade 1 full mock AP for you in an AP style. Yeah. But, Eurus, whatever one you don't take, both of them are going to be posted in our very secure class. Actually, no, I can't even do the shared folder. I can do it in the classroom, though, because that's only you guys. It's limited to you guys. The other one will be posted when you go through and do corrections after it's been graded, so you can take the other one as a bonus practice exam. Does that make sense? So you'll have a chance, just not in the testing format and not with me grading it. Is that cool? But good question. Excellent question. So Saturday or Wednesday, I want you guys to commit. Now, if something, like, oh, how do they always put it? Oh, like the insurance companies and stuff. Anyway, some act of God. It is, we have Wednesday, and you will have to come. Some France people, you're like, no. Can you sign Joyce up here too? So go ahead, put your name on one of them. You guys have had more than enough time to figure out which one you are. I just need to plan ahead as far as copies. I'll make a couple extra copies. Actually, I'll probably wait to do Wednesdays until we get back, but I need to know how many copies to make without killing too many trees. Okay. And how much food to make, et cetera, et cetera, et cetera. It's this whole thing. Remember this Saturday, 8 to noon. You can come a little bit early. Actually, I would advise it. No. Yeah. You can come at like 7:45. I mean, some of your parents might drop you off way earlier, Lo siento, but it is what it is. But yeah, 8 to noon. And then on Wednesday, it's from, because I wanted to start it right away, 3 to 7. And there aren't any games on Wednesdays, et cetera, so we should be good with that. All right, cool kids. To that end, 2008 multiple choice. All right. Let's talk about our calendar really quickly, because I have told you that we are to have this done by the end of the week. However, that's a little bit awkward in some senses, because I do not want to take away from you practice exams that you have attempted and corrected and have things to study on before your mock AP. So on Friday, I do have right now, go ahead, Allie, what's up?
Saturday, where do we meet?
Library. My room or library, either one. I'll be going back and forth probably. Okay, sorry. The when you see you think is due fully attempted on Friday, but this is something where I'm walking around the room and having you guys go to random sections, and I'll see if it looks like you have it fully attempted. Okay? Tomorrow I'll go ahead and show you in class. I'll post one version of an answer key, but you guys remember that we've talked in detail about how the when you see you think is what your brain needs to remember when you see a certain topic or a certain direction or a certain given piece of information. Guys, do I think that your when you see you think is going to be perfect by Friday? No. I just want you to have thought through every single one at least a little bit. So maybe you only have like 1 or 2 words, maybe you have one equation, maybe you have one little line. But I want you to have thought through every box. But we'll probably be adding to it after spring break. Does that make sense? Okay. So just having thought through every box at least shown me that you've worked through it. But I will post one version of an answer key so that you guys can access. Like, I don't know what this box is talking about. How do they answer it? Oh. Or, I still don't get it. But anyway, that's due by Friday. Me walking around the classroom. I'm not taking it away from you. Okay? If you guys notice what we're doing in class, today we're doing questions on the calculator multiple choice. Tomorrow, questions on the non-calculator multiple choice. The next day is questions on the calculator FRQs, which are going to be 1 through 3. And then the last day questions on the non-calculator FRQ. So by Friday, you should have the whole 2008 attempted and graded, and we've had a chance to go over questions. Does that make sense? Okay. And if for any reason you're gone any of these days, I will be recording. Cool? But I don't want to take from you the 2008 exam. So on Friday, the same way I walk around looking at the When You See You Thinks, I'm going to be walking around and looking at your 2008, the 4 portions, but I won't be taking it from you. Now, as I look at it, how am I going to give you 100%? What am I going to need to see? You guys just be smart, think like a teacher for a second. Yeah, stuff done in pencil, stuff marked in red pen as far as right, wrong, and corrections, that you've been asking questions and you've been filling in the things that you didn't get. Does that make sense? Can you reproduce all of that Thursday night if you totally blow up this assignment? I don't think so. It would be brutal. It would be awful. It would be horrible. It would be unwise. So that's why I'm trying to give them a chance in the back to just take it. That way they don't fall behind. They can grade it tonight and then keep going from there. But also for you guys, how often does a calculus assignment only take 45, 50, 55 minutes? Not very often. So in a way, it should be nice that you just have to set a timer, do your best, bring it in the next day. Does that make sense? In a way, it should be a blessing. I know it kind of might feel like, oh my goodness, so much work. But you guys we need to get a practice exam under our belt before Saturday, right? Or for those of you guys who are taking the bonus one before next Wednesday. So all of us by Friday should have the 2008 fully attempted, graded, right, wrong, A, B, C, etc. But then also the ones you get wrong, having some explanation, some sort of work. Not everyone, some are idea problems, so writing yourself little notes, etc., that you can use to study. Does that make sense? What are we not having that we probably should? A forever quiz. Why should a forever quiz be this Friday? But frankly, because of people being absent, being gone, and the spring fling and all sorts of stuff, I'm just not going to do it. It kills a little part of me inside. But why should we have a big forever quiz? Yes, you're forced to study. But do you guys know you need to know your forevers by Saturday? Or by next Wednesday? Over spring break, I mean, ultimately we're working for the actual AP. But we're also working for our final. Ultimately, I will be having you guys do another quoting assignment over spring break. That's why I was mentioning yesterday, like even my France kids, you can take forever cards. There is going to be another quoting assignment, which some of you need to be handwriting. Quoting doesn't cut it. But for some of you, just the repetition of saying it out loud, of reading it, it is cementing it into your brain. We're going to have a large forever quiz right after spring break. And then we're going to have our forever final on all the cards. Same thing with the large forever quiz on all the cards closer to the actual AP. Like the week before, probably around Wednesday of the week before the AP. Maybe Thursday or Friday. Just so you guys know that's coming, but also so you hear from me, there's not going to be a quiz this week just because we're doing so many other things and the schedule's so busy. But if I were you, I'd be carrying around your forevers. And on Friday night, to be honest, maybe looking at this, that, or the other, but especially making sure you have the forevers. Does that make sense? Yeah.
I don't know if you said this, but when is the 2003?
Yeah, that's my next one. Good, Grace. She's asking about the bonus exam that's in your guys' shared folder. First of all, any questions about how to find that bonus exam? Are we good? Okay. Bonus exam. I haven't been super detailed about the bonus exam. The bonus exam is worth +4 extra credit points in your test quiz category. Every bonus exam that we take up until the actual AP. Now, some are required. 2008 is not worth +4. It's an actual homework assignment, basically like a homework packet. Like a whole homework, a whole chapter's homework. But the 2003 is worth +4 points, like some test in your grade going up 4. Does that make sense? But what needs to happen is it needs to be printed out, number 1. It needs to be attempted, graded, and corrected, and you guys have all the information online. Here's where the deadlines are going to be a little weird. In theory, Grace, it's due Friday, but I'm not going to take it from you Friday, and I'm not going to walk around and check it Friday. Because some of you might want to take it closer to your mock AP. Meaning, I want to give those of you who are like literally on a plane on Friday, not the pressure of having to fit in a bonus, then have a whole week, and then, oh well, let's go take a mock. I want you to be able to take it maybe the Easter Monday or the Sunday or the Tuesday before your mock AP. So I'm not going to be collecting it until Wednesday. or checking it until next Wednesday. Now, those of you guys that are taking the mock AP Saturday, it'd be wise to get another bonus practice exam in before Saturday. And it'd be like if you have extra questions on it, and Friday, if there's some extra time, you can ask me on the 2003. But I think it's only fair if I say, hey, yeah, for the people taking it Saturday, you should take it by Friday. And the people taking it next Wednesday, you should take it by Wednesday. Does that make sense? Or by Tuesday. So for everyone, the actual bonus 2003 that's due right now for your mock won't be due until after spring break. And so for a few of you, you're like, there's no way I have time now. But you would have time over spring break. So even if you can't get it done before your mock, that technically is the bonus one to have done by after spring break. Is that cool? Yeah, AJ. I would. Because remember, we're going to get those packets that go deep into limits and deep into derivatives and deeper than the 27 essentials. That's where we can access our notes and our forever cards and this, that, and the other. But whenever you're taking a bonus practice exam, my advice, and that's what we're doing in class 2, is just to time it, because then you're seeing what mistakes you're making, what words you're coming across that your brain freaks out on, etc. Yeah, and I'm not giving you better credit for getting 100%, right? You're just testing your brain, and then when you grade it, then you're like, okay, well, let's go figure out why. Is that cool? Yeah. All right, any quick logistical questions? I know I threw a lot at you, but I was just trying to give you a good view. Plus, I don't know, like Joyce was gone today. I don't know if you guys will have to miss this week, etc. Yeah. No pictures, no Google Classroom. It's just me walking around and checking. Because to take pictures of all of them would be so annoying. So yeah, don't worry about it. Grace.
So if we're going to be gone Friday, should we try and have this happen Thursday?
You can show me in class on Thursday. Yeah. That works. So if you're gone Friday, if you have your when you see you think. No, let me not pressure it. I'll just check it the Tuesday we get back. Same idea with your mock not being until Wednesday anyway. Yeah, that way you guys don't have to because you'd have to take the exam early, and I think that'd be a mess. I not want you when you're packing for France the night before having to worry about pictures on Google Classroom. That's horrible. Okay, any other questions? Cool. Now we can stand up, give everybody around us a high five, a pat in the back really quickly, because we've been sitting and you've been just listening to me blah, 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 blah. We have to go over questions on these multiple choice. But let's quick. Recenter, care about the people around us, or just stay seated. All right, here we go. Starting with number 76. Why do they do this? I don't know. When we take our mock AP, it's going to be on a standard 100-question Scantron. So you're going to take multiple choice, the non-calculator, 1 through 30, and then you're going to flip the Scantron. I think that's partially it. So if you got off, you're not still off. I think that's part of it. But whatever, they started at 76, and our Scantron, we're going to start on number 76 too. It is what it is. It's weird, but we're fine. But it started at number 76, and it went through, 90-something. You guys just graded. Let me show you really quickly that answer key. Oops. Here we go. The answer key with diagnostics. Okay. What this is talking about, if you guys were wondering what all those other numbers were, this is the question number. This is the correct answer. And then it's percent correct by grade. So of the people who got 5s on the exam, the highest possible score, for each of these that you guys just checked, 98% got number 76 right, 89, 97, 81, 70. Ooh, what does this tell me? It's a harder question. Only 40% of the total kids got it right. Does that make sense? So we can kind of see which ones are harder or not. So if you guys want to, before I take away this, or you can maybe look at it in more detail tonight, these are how many 5s, 4s, 3s, 2s, 1s got it right, and these are the percentage of total kids that got it right. So you could go through, and even though a lot of the 5s got this one right, number 89, only 50% of the total kids got it right. So you could go through and be like, okay, anything under 50%, ooh, that was a bad one. Anything under 50%, ooh, number 85 was a bad one. Number 87 was a bad one. Oh, look at 89 and 90. 32 and 30% of kids got it right. That's rough. And then number 92. So if you guys want, you can put little stars by those. If you got them right and you understood them, excellent job. If you got them right by guessing, well, it was hard. But the ones under 50% were number 80, number 85, 87, 80, 85, 87, 89 and 90 were the worst out of the entire calculator portion, and then number 92. I don't know, it just makes me feel a little bit better about it. Well, at least maybe it makes me feel a little bit better about it. This year, they actually threw out number 19. It says it wasn't used in scoring for statistical reasons. They say that a lot of the kids who did well, that was number 19 though, you guys haven't done that yet, but every year there sometimes are questions they in a sense throw out or they don't have count towards your score. So they are considering you when they are grading, and they are trying to look and analyze as to how well kids are doing and how well they're doing their test or the test. The curving, the assigning of 1s, 2s, 3s, 4s, and 5s definitely considers the students and how well you guys do. So I'm going to tell you approximately to get a 5 you need a 65%, but some years actually the test is a little bit easier in some ways, and they actually determine this with sample groups years before, and every year there's like sample questions that are thrown out, but not all the sample questions of an AP, and then they see how kids do on those sample questions, and then they kind of compile, and it's this whole machine of a process. But they are considering students, and so the exam that you take this year, it may feel really hard and the curve is really good, or it may feel really easy and the curve is really bad. To be honest, I'm encouraged when kids are like, it was brutal, because I'm like, whew, maybe we have a nice curve. That's what last year was, to be honest, in many ways. So those are just the strict answers and then the percentages, but then I do have, remember I'm giving you these exams because there are resources. I do have a 2008 multiple choice exam fully worked out. So I'm pulling this up as well, starting with number 76, so that we can go over ones that you guys want to look at with one version of the solutions. I'm going to go ahead and post this in Google Classroom. Let me show you what I did for BC. I'm going to do something similar for you guys starting tonight. But I didn't want to throw it up last night because I didn't want the solutions readily available. A few of you guys are still learning how to wisely use things like answers. So for BC, and so are they, but they just know by now they're wasting their time if they try to do it any other way. Oh, hey, there you go. So what I did for them is I did a quick little logistical reminder. It's not an assignment, it's just like an announcement. I'm going to do that for you guys too so that you can kind of stay organized, and Google Classroom is where most of us look to do that. And then I went ahead and posted for them their 2008 AP BC. I went ahead and posted, Mr. Calculus's website goes through and shows like solutions, not only the right answers, but also the solutions. I'm going to do something similar for you guys, but instead of sending you to Mr. Calculus, which is good, I'm going to go ahead and instead do the answer key with like all the different letters. So you can quickly grade it, and then I'm going to give you this sample multiple choice that's all marked out. So I'll give you resources. If you want to grade it before class, that's totally fine. If you want to start thinking about the questions that you have, the ones you can narrow down, that's totally fine. But just for today, you just graded. What did you miss? What did you miss? It could be from the very beginning. I don't care. What did you miss? 81? Anything before 81? 78? Anything before 78? 80? Okay. So number 78, then 80, then 81. The first derivative is defined by f prime of x is equal to sine of x cubed. On what intervals is f increasing? What should we be thinking of with f increasing right here? F prime is greater than 0. So as soon as we see this, according to our forever cards, we think f prime greater than 0. Here is f prime, so I need that to be greater than 0. Hey guys, how can I tell when this is greater than 0 if I can use my graphing calculator? Graph it in radian mode. Wait, but what about my window? Who's my x min in my window? 0. Who's my x max in my window? 2. What am I looking at? The axis and when it goes above. What can I use as a feature to figure out the point at which something goes above or below? The 0 feature, right? And so we're looking for when the graph is above using the 0 feature, and it ends up crossing the axis somehow at 1 and at 1.691 and somehow going above. Does that make sense? Okay. Number 80. Is it important to know how to use your 0 feature? Number 80, the derivative of the function is given by, you guys don't like being given derivatives. How many points of inflection does the graph of f have? Hey guys, is there even, like, you guys should have your calculators out. This is the calculator multiple choice, right? Is there even an option in second trace for points of inflection? Like, is there any mathematical way from our calculators to find points of inflection given an original graph? They're not there, right? Okay. So if you're looking at an original graph, we know points of inflection are where concavity, up, down, concavity, down, up, where concavity changes, but there is no way to use your calculator on an F graph to find it. There's no point of inflection option. But guess what we can do on an F prime graph? Do you guys remember how, and maybe you should look at your forevers, or maybe just make a note to yourself to go back and review. On your forevers, don't I talk about how F double prime being greater than 0 or less than 0 relates to F prime changing from increasing to decreasing? F double prime being positive, negative is F concave up, concave down, F prime increasing, decreasing. Do you remember how I tied all three of them together? Why is that helpful? There will be a point of inflection anytime F prime has a relative max or a relative min, whether it's smooth or whether it's sharp. Anytime F prime changes from increasing to decreasing or decreasing to increasing, some of you might need to add that on your actual inflection point forever card. There will be a point of inflection anytime F prime changes from increasing to decreasing or decreasing to increasing. And why is it such a big deal? Because can your calculator find maxes and mins? Yes. So for points of inflection, even if I had F's graph, I could look at it and say, oh, it looks like concavity is changing, but I couldn't find it. But if I have F prime, I can find maxes and mins. And if I had F double prime, I can find, let's see, that would be here-ish, that's a 0, that's a 0, that's a 0. So many zeros. That's a 0. That's a 0. F prime is decreasing, so negative. F prime is increasing, so positive. F prime is decreasing. Something, which makes sense because it's a 1, 2, 3, 4, 5, 6 degree, and this is a 1, 2, 3, 4, 5, 5th degree, 6th degree, 5th degree. Yeah, that would make sense with the derivatives. F prime, I could find my maxes and mins. F double prime, I can find my zeros. I can use max min feature. I can use zeros feature. So for points of inflection, if I were you, I'd make a note. If you ever need to find points of inflection with your calculator, you can't look at F. Either look at the relative extrema of F prime or the zeros where the function goes through, changes signs on F double prime. So either way you count it, 1, 2, 3, 4, 5, or whether you took the derivative and graphed it, 1, 2, 3, 4, 5. There are 5 points of inflection. Good question. Number 81. Ooh. Look at all these concepts in number 81. G is an antiderivative. So couldn't I say, wait, where do antiderivatives come from again? Integrals, right? So can't I say the integral of f of x dx is equal to g of x? In general? Antiderivatives. The integral of f of x dx is equal to g of x plus c. The integral of f of x dx is equal to g of x plus c, the antiderivative of f. But then they start giving me numbers. Do you guys see, just looking, don't you see bounds? Doesn't that start to make sense? Oh, so it's a definite integral, not an indefinite integral. So if I was to do from 2 to 4 of f of x dx, what would the fundamental theorem of calculus tell me? Antiderivative of b minus antiderivative of a, right? Or couldn't we do integration as net change, say final equals initial plus? We could move that to the other side. Oh, and I need to move it to the other side, because what do they want me to solve for? Yeah, move him. Oh, it is integral as net change. G of 4 is equal to G of 2. The final is equal to the initial plus the change. And all I have to do to finish off and be like, but he's not there. Oh, who is this guy? Dun, 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 dun. So the answer is, that's weird, E. Sorry. Okay, I've gone through 78, 80, and 81. I'm ready for more. Tell me what you missed. Let's go talk about it. 86. Ryan, what else?
82.
Okay, we'll do 82 and then 86. And Ale?
84.
Cool. 82, 84, 86. Anything else in between 86? 82. Motion. It's physics time, yeah? A particle moves along a straight line with a velocity. Hey, they give you a derivative again. Isn't velocity position prime? What is the Oh, guys. It's a calculator question. How do we move from velocity, From velocity to acceleration? Derive. And what can your calculator do? Oh my goodness, how do you find a derivative on a calculator? You can go to the math and go down, or isn't there a shortcut in the alpha? Isn't it alpha window? Either way. Either way. Choose a way and stick with it. Alpha window. This is literally, can you plug it into your calculator? Literally. Can you plug it into your calculator? Because doesn't your calculator, as soon as you hit the derivative function, doesn't it let you put in d dx? Doesn't it let you put in a function 7 minus 1.01 to the negative x squared? Whatever. And doesn't it ask you for which? Oh, free points. We love free points. Yeah? But make sure you're in, well, I would say radian mode, but there's no trig. Doesn't really matter. Be in radian mode. Okay. 84. The graph, oh, we got to see that, don't we? Okay. The graph of f prime. The graph of f prime is given to us. The graph of the derivative of a function f is shown in the figure above. The graph has horizontal tangent lines at. The graph has horizontal tangent lines at. They're just telling me exactly where these are so I don't have to second guess. The AP is very precise. They're like, it looks like negative 1, 1, 3, but no, we'll tell you negative 1, 1, 3. You can bank on it. At which of the following values of x does f have a relative, does f have a relative max? Does f have a relative max? Question. On this one, this is number 84, right? If we were to go to our quick answer key, solutions with number 84. %58 of the kids got it right, but that means 42% got it wrong. True? Now, the majority of fives, if you get the concept, it's a really easy question. If you don't get the concept, well, it starts to get harder and harder and harder. Ooh, 14% of ones got it right. Now, you can get a 1 and still have a good comprehension. Like some of these kids got 1s, but they still, like some of these kids were getting some of these right. But what gap of understanding was there, especially for the ones, in this question? What do you think people thought wrong? Probably the ones all answered D. At least the majority of the ones answered D. Because they're like, oh, look, it's a relative max, yeah, you're done. Now, maybe some of the 3s and the 4s did that too, maybe the 2s. But the majority of the ones probably said, this is easy, letter D. Calculus isn't going to say, find me the max of a graph that you're looking at. Come on. This is not F. Who is he? Come on. Look out. Look out for the deceiving ones, yeah? That's a life lesson. Look out for the deceiver. It's going to look so good. No. Is it 4 only? First derivative test. There will be a relative max when f prime equals 0 and changes from positive to negative. And if this is f prime, y equals f prime, the graph changed from positive y values to negative y values. Where does the graph go from above to below? And some of you can put this in your forever card under the first derivative test. F prime changes from positive to negative. Graph of f prime changes from above to below. Only at 4. This one's above to above. This one's below to above. My f is decreasing and then increasing, increasing, then increasing, increasing, then decreasing. There he is. Only at 4. That was 82. That was 84. We're going to 86? Yeah, that was yours, right? Sorry, wrong one. Choop. Oof. The tables tend to get nasty. Because a lot of you want to smoothly connect the points and you can't. These are selected values of velocity, right guys? But what is our question asking us about? Position. True? Now, what this person did, what this answer key did, is they went ahead and graphed the points, which is not bad, just very dangerous. There's 0, -1. There's 2. Are they going by 2s? Oh, no, 1, 2. Sorry. 1, 2. There's 3, 2. 2, 3. Stink. I am reading this backwards and I don't know. I apologize. There's 1, 2. There's 2, 3. There's 3, 0. And there's 4, -4. Okay. Could you connect it like that? Sure. Could you connect it like? No, you can't do that because that would make it not a function. Can do it that, as long as it doesn't say something about continuous and differentiable. Now, position's always continuous. You're not going to just randomly be moving and then bloop, you're not there, and then bloop, you're back. Unless you believe in sci-fi, but no. So it will be continuous, but it could go all sorts of different ways, guys, in between each of these points. So it's not necessarily that, but this gives us an idea. At time t equals 0, the particle is at the origin. So first of all, the particle's at the origin. Well, why am I crossing off these? Is the position at 0, 0 for those? Well, forget that. And then down here, well, I have to look at this guy. Okay, so these three, all of them start off with the particle being at the origin at 0. Okay, good. But then it says, which of the following could be the graph? Guys, what's the velocity at 0? Negative. What does that mean about the slope at 0? Or what my position is doing at 0? Decreasing. So I need a, oh, forget him. He increases right away. Nope. He decreases. He decreases. Okay, cool. What else is going on? Do both of them have a leveling off at 3? 1, 2, 3. Yeah, leveling off. 1, 2, 3. Yeah, leveling off. Okay, that doesn't work. Do both of them have decreasing at 4? At 4, going down. At 4, going down. Yep. Increase at 2, going up. Going up. Yep. An increase at 1, going up. Only he has at 0 decrease, at 1 increase, at 2 increase, at 3 level off, at 4 decrease. It's the best way I know. I'm trying to figure that one out. Yeah. 85, 89, 87. Okay, so 85. Oh, it's so easy, it's hard. What does FTC tell me about solving a definite integral? Any definite integral is equal to the antiderivative of b minus the antiderivative of a. Who's the antiderivative of f prime? F. Go to your table, plug it in, plug it in. So easy, it was hard. 87. Integration is net change. How do I find the position at? Not the change over, not displacement from physics, not just the change that happened, but where is it now? I need to know where it started. I need to know where it started. So I need to find x of 3, I need to know x of 0 plus the integral from 0 to 3. That's integration is net change. But if you were just thinking about it, hopefully you would have thought that x of t is equal to the integral of v of t dt. However, if I'm trying to find an actual x of b, that only comes from a definite integral. And so if I want to know one, I need to add the other. That's what integration as net change does. But final position needs initial position plus the change in. And then number 89, if there is no c, wait a minute, no c where the derivative is 0, but Rolls says if a function is continuous and f of a equals f of b, that must be true. No. Rolls says if a function is continuous and what did they not say it was? So what could have made it fail? The derivative must not exist, aka it must not be differentiable, or else that would have to be true. Ooh. So nice, so good. E is the correct answer as a result. Could we have a couple more questions here and there? Yes, but what am I posting tonight for you guys to be able to access? The solutions to what? All the multiple choice, because you are going to take a non-calculated multiple choice on the way out the door, and you can come tomorrow even with it graded with questions already if you so desire. Sound good? I'm going to take a little more time with this answer key. Bye, guys. 55 minutes. 55 minutes. Non-calculator. Nick, I'm sorry. There you go. Sorry. 55 minutes. 55 minutes. Did you get some done? 55 minutes. There you go. 55 minutes. Did you get some done?
Yeah, I
Good.
got the majority of it done.
Good.
There was just a couple questions that I was like, oh, I have no idea how to do this.
That's all right.